So I'm going to be solving for x for this problem. So I'm going to start by using the Pythagorean identity. And so I'm going to be substituting 1 minus sine squared x for cos squared x. I'm then going to simplify and then put everything on the same side. And now, by making sine x equal to u, I'm going to make things slightly simpler. I'm now going to factor Now we see that negative 2u plus 1 equals 0, and u plus 2 equals 0. And u equals 1 over 2, so substituting sine x back in, get that sine x equals a half. On this side, u equals negative 2, so sine x equals negative 2. Thank you. Okay, so we have that sine x equals a half. Now we know that sine x equals opposite over hypotenuse. So we come out here and we look at the special triangles, and we see that in order for 1 to be the hypotenuse and 1 to be the opposite and 2 to be the hypotenuse, we have to use angle 30. So 1 is the opposite and 2 is the hypotenuse. So then we get that sine 30 degrees equals 1 over half. And now looking at the unit circle, we know that 180 degrees is equal to pi. 90 degrees is pi over 2. And so that means 30 degrees is pi over 6. So then we know that sine pi over 6 equals a half. And looking back at the unit circle, we know that in the first quadrant, all trig equations give a positive answer. In the second, only sine gives a positive answer. In the third, tan gives a positive. And in the fourth, cosine. So then we know, since our answer is positive, and since we're using sine gives a positive answer in quadrant 1 and quadrant 2. So we already found the answer, the angle for in quadrant 1. Now in quadrant 2, we find it by finding the reference angle, so that the reference angle equals pi over 6. And the reference angle is the angle between the x-axis and the terminal side. So this means then that the actual angle is 5 pi over 6. So sine 5 pi over 6 also equals a half. So this means that x equals pi over 6, and x equals 5 pi over 6 as well. So then in our next equation, for this one we can't solve, because we know that sine x has to equal the opposite over the hypotenuse. And this